Okay, for chapter 2 is logic. In this chapter, we have the truth table. The truth table will cover about negation table, conjunction table, disjunction table, and biconditional table, and implication table. And then in this chapter, we have also have argument. In argument, we have a symbolic of argument and rules of inference.
Hi, Assalamualaikum. Today I will present to you about truth table. So definition of truth table. Truth table is a diagram in rows and columns showing how the true or falsity of proposition varies with that its component. T in the table stands for true statement, while F stands for false statement. If the compound statement has two variables, let's say P and Q, then the truth table must be constructed with 4 rows. It can be simplified into formula below. 2n, where n is the number of variables. Negation. Let P be a proposition. The statement, it is not the case of P, is another proposition called the negation of P, denoted by negation P. So, P is true, negation P is false. P is false, negation P is true. For the example, P, Omar is tall. Negation P, Omar is not tall. Conjunction. Let P and Q be proposition. The proposition P and Q, denoted by P and Q, is proposition that is true when both P and Q are true, then false otherwise. P and Q is called the junction of P and Q. Let's say P is true, Q is true, P and Q is true. P is true, Q is true, P and Q is false. P is false, Q is true, P and Q is false. P is false, Q is false, P and Q is false. For the example, P equal is big, Q equals is handsome, P and Q equal is big and handsome. Disjunction. Let P and Q be proposition. The proposition P or Q, denoted by P or Q, is proposition that is false when both P and Q are false, then true otherwise. P or Q is called the junction of P or Q. Let's say P is true, Q is true, P or Q is true. P true, Q false, P or Q is true. P false, Q true, P or Q is true. P false, Q false, P or Q is false. For the example, P, Hairul wants to go to work. Q, Hairul loves reading book. P or Q is Hairul wants to go to work or he loves reading book. Implication. Let P and Q be proposition. The proposition P or Q, denoted by P implies Q, is the proposition that is false when P is true and Q is false, then true otherwise. P is called the hypothesis or antecedent of premise, and Q is called the conclusion or consequence. Let's say P is true, Q is true, P implies Q is true, P is true, Q is false, P implies Q is false. P is false, Q is true, P implies Q is true, P is false, Q is false, P implies Q is true. For the example, P, Muhammad is hardworking, Q, Muhammad is smart. P implies Q is, if Muhammad is hardworking, then he is smart. Biconditional. Let P and Q be proposition. The biconditional statement of P if and only if Q, P arrows Q is the proposition that is true when P and Q have the same true values than false otherwise. Let's say P is true, Q is true, P arrows Q is true. P is true, Q is false, P arrows Q is false. P is false, Q is true, P arrows Q is false. P is false, Q is false, P arrows Q is true. For the example is P, Hazmi eats apple. Q, Hazmi got permission from his mom. P arrows Q, Hazmi eats apple if and only if he got permission from his mom. Example 1. Show that P implies Q and negation P and Q logically equivalent with negation P and Q by using truth table. For the solution is P, true, true, false, false. Q, true, false, true, false. Negation P, false, false, true, true. P implies Q, true, false, true, true. Negation P and Q, false, false, true, false. P implies Q and negation P and Q, false, false, true, false. So we can see negation P and Q and P implies Q and negation P and Q is same. So the conclusion is P implies Q and negation P and Q eros negation P and Q. The example 2, using truth table, determine the validity of the given argument. For premise 1, P implies Q. Premise 2, R and P. Premise 3, negation Q. Conclusion is P. For the solution is P, true, 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 false, 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 false. Q, true, true, false, false, true, true, false, false. R, true, false, true, false, true, false, true, false. Negation Q is false, false, true, true, false, false, true, true. P implies Q is true, true, false, false, true, 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 true. R and P is true, false, true, false, 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 false. P implies Q and R and P is true, false, 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 false. P implies Q and R and P and negation Q is false, 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 false. P and Q and R and P and negation Q implies P is true, 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 true. So the conclusion is, since P implies Q and R and P and negation Q implies P is a tautology, so the argument is valid. So the example 3, using truth table, determine the validity of the given argument. Premise 1, P implies R. Premise 2, R implies Q. Premise 3, negation Q. Conclusion is Q. Solution, P, true, 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 false, 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 false. Q, true, true, false, false, true, true, false, false. R, true, false, true, false, true, false, true, false. Negation Q is false, false, true, true, false, false, true, true. P implies R is true, false, true, false, true, 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 true. R implies Q is true, true, false, true, 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 false, true. P implies R and R implies Q is true, false, 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 true, true, false, true. P implies R and R implies Q and negation Q, false, 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 true. P implies R and R implies Q and negation Q implies P is true, 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 false. For the conclusion is, since P implies R and R implies Q and negation Q implies P is not a tautology, so the argument is not valid.
So hi, Assalamualaikum. I want to explain about the definition of argument. Argument is a list of given statement called premise, followed by the final statement called conclusion of argument. So this is the symbolic of argument, where H1, H2, H3 and Hn are hypotheses and C is the conclusion. The hypothesis consists of a list of one or more proposition or premise. So, in the argument, we have the rules of inference. So, the truth table are not practical to determine validity of argument involving more than 3 propositions. In order to avoid large truth table, a list of technique called the rule of inference was developed. So, I want to explain 8 rule of inference. So first, we have the modus ponens. Next, we have a modus tollens, and then we have a law of syllogism, and then we have a disjunctive syllogism, and then we have a disjunctive amplification. Next, we have a conjunctive simplification, and then we have a rules of conjunction, and then we have a proof of resolution. So for example 1, if Ikhwan studies, then he passed the test. He is smart or he studies. He is not smart, therefore he passed the test. So the premise 1 is, if Ikhwan studies, then he passed the test. For premise 2, he is smart or he studies. And then for premise 3, he is not smart. So the conclusion is, he passed the test. So let's assume that P is Ikhwan studies, and then Q, he passed the test, and then R, he is smart. So the symbolic of argument is premise 1, P implies Q, and then for premise 2, R or P. So for premise 3, negation R, and then the conclusion is Q. Okay, so for example 2, solve the following argument by using rules of inference. So the question is, P implies R, and then negation P implies Q, next Q implies S, and then the conclusion is negation R implies S. So we must find how we get the conclusion. So we skip to the number 4, is a combination of 2 and 3. We use law of syllogism, And then we use number 1, we contra positive. And then for number 6, we combine 4 and 5 with law of syllogism. So we get the conclusion is negation R imply S. So for example 3, the question is, if Alif and Dila listen to the music, then Dila will not play piano. If Alif does not sing a song, then Dila will play piano. Alif does not sing a song. Okay. So for question A, write the primary proposition using the variable P, Q, R and S. So P, Alif listen to music. Q, Dila listen to music. R, Dila play piano. And S, Alif sing a song. So for B is, write all the hypotheses or premises using the variable in A. So the premise 1 is P and Q implies negation R. For the premise 2, negation S implies R. And then for premise 3, negation S. And then for the C, use the rules of inference to prove the conclusion of the argument. For number 1, 2 and 3, we got from premise 1, premise 2 and premise 3. And then for number 4, we got from the 2 and 3, we use the modus ponens. And then for number 5, we got from the 1 and 4, we use modus tollens. And then for number 6, we use De Morgan law. So for the number 6 is the conclusion. The conclusion is negation P or negation Q. That means, in conclusion, Alif or Dila not listen to music.
Chapter 3. Proof. There is 7 topics in this chapter, but we will only present to you 2 of it, the forward-backward method and the contradiction method. Forward-backward method. The forward-backward method is a proof technique used to demonstrate that if A, then B is true by following 2 complementary processes. Backward process. Start by asking an abstract case question. How or when can I conclude that B is true? Give an abstract answer to the key question. Apply the abstract answer to the specific situation. Obtain a new statement B1 with the property that proving B1 true will prove B is true. Forward process. Begin with statement A hypothesis assumed to be true. Derive statement A1, A2, etc. from A. The goal is to link up with the last statement in the backward process.
Example 1. If a right triangle XYZ with sides of length x and y and hypotenuse of length z as an area of n squared over 4, then the triangle XYZ is isosceles. So we can get the hypothesis A, right triangle XYZ with side of length x and y and hypotenuse of length z has an area of n squared over 4. Conclusion B, the triangle XYZ is isosceles. Now we will do the backward process. B, triangle XYZ is isosceles. So we can get the B1 is x equal to y. And now we will do the forward process. A, triangle XYZ, side of length s and y, hypotenuse length z, area z squared over 4. A1, area z squared over 4 equal to 1 over 2 times base times height. A2, z squared equal to x squared plus y squared is a Pythagoras theorem. A3, we substitute it, so we got z squared over 4 and 1 over 2 xy. A4, we got x squared plus y squared over 4 equal to 1 over 2 xy. We divide with 2 both sides in A5, so we get x squared plus y squared times minus 2xy equal to 0. At A6, we simplify, so we got x minus y and x minus y equal to 0. In A7, we got x equal to y. As you can see, A7 logically equivalent to B1. That's all for example 1.
Okay, so now, for example 2. The question is, if x is odd and y is odd, then xy is odd. So, with this question, we get the A, x is odd and y is odd as hypothesis. and B xy is odd as conclusion. So now we will do the backward method. B1 xy equals to 2k plus 1. We got this from the definition of odd number. And now forward method. A1 s equal to 2a plus 1. A is an integer. A2 y equal to 2b plus 1. B is an integer. Both of it we got from the definition of odd number. A3 xy equal to 2a plus 1, 2b plus 1. That we get from substitute the x and y. And we expand and we factorize it and we get 2ab plus a plus b plus 1. Now we will do the let k equal to 2a plus 2ab plus a plus b, and we will get the xy is equal to 2k plus 1. And now we can see A4 is logically equivalent with B1. Example 3. If n is an even integer, then 3n plus 1 is an odd integer. From this we get the n is an even integer is A, the hypothesis, and 3n is an odd integer is B, the conclusion. So now we will do the backward method. B, 3n plus 1 is an odd integer. B1, 3n plus 1 equal to 2k plus 1. K is integer. That is the definition of odd number. Forward method. A, n is an even integer. N equal to 2a. That we get from definition of even number. And now we will substitute n. 3n plus 1 equal to 3 to a plus 1. And we will expand. We got 6a plus 1. And we factorize. We got 3n plus 1 equal to 2, 3a plus 1. Now we substitute k with 3a and we will get the 2k plus 1. From this we see that A4 logically equivalent to B1.
Next is the contradiction method. Why we use contradiction method? We use contradiction method because the forward method or direct method is not always successful. How and when to use contradiction method? In proving by contradiction, assume that A is true and B is false. Example, not B is true. Using the information in the forward process to reach a contradiction. Therefore, in the contradiction method, we have two statements, A and not B, to reason forward. In general, use the contradiction method when the statement not B gives some useful information. This happened in two instances. One, when B is one of two possible choices. Example, B and is even, not B and is odd. 2, when the statement B contains the word no or not. Example, B is m square is not equal to A plus B, and not B is m square equal to A plus B. Example 1. If x square minus 3x plus 2 is greater or equal to 0, then x is less and equal to 1 and x is greater and equal to 2. Your answer should have an analysis of the proof and the condensed proof. For the analysis of the proof, we can hypothesis that A is x square. We can put A as x square minus 3x plus 2 greater or equal to 0. And for conclusion B, x is less than or equal to 1 or x greater or equal to 2. We can take it forward for not B, and A1 is x greater than 1 and x is less than 2. This statement is not B. A2 is x minus 1 greater than 0, x minus 2 less than 0. For A3, x less than 1 times x less than 2 is less than 0, and A4, x square minus 3x plus 2 is less than 0. From this, we can see that x square minus 3x plus 2 less than 0 contradicts the hypothesis A. For condensed proof, assume to the contrary x greater than 1 and x less than 2, not b, and x squared minus 3x plus 2 is greater or equal to 0. Hence, x minus 1 greater than 0 and x minus 2 less than 0 implies x minus 1 times x minus 2 less than 0. Therefore, x squared minus 3x plus 2 less than 0 contradicts the initial assumption. Example 2. If n is integer and n squared is even, then n is even. Analysis of the proof. Hypothesis A, n is an integer and n squared is even. Conclusion B, n is even. N1, n is odd, which is not B. A2, n equal to 2k plus 1, and k is z. A3, n square equal to 4 times k square plus 4k plus 1, which is equal to 2 times 2k square plus 2k plus 1. We can let a is equal to 2k square plus 2k, and a is z. A4, n square is equal to 2a plus 1, and A5, n square is odd. Thus, this shows that A5 contradicts with A. Condensed proof, assume to the contrary, n is odd. Let n equal to 2k plus 1 and k is z. Hence, n square equal to 4k square plus 4k plus 1, which is equal to 2 times 2k square plus 2k plus 1. And then we can let a equal to 2 times k square plus 2k, and a is z. Implies that n square is equal to 2a plus 1. Therefore, n square is odd, contradicts the initial assumption. Example 3. If a and b is z, then a square minus 4b minus 3 does not equal to 0. Analysis of the proof. Hypothesis A and B is z. Conclusion B, a square minus 4b minus 3 does not equal to 0. A1, a square minus 4b minus 3 equal to 0, which is not B. A2, a square equal to 4b plus 3. A3, 4b plus 3 is odd, so a square and a is odd too. A4, a equal to n plus 1. A5, a square equals 2n plus 1 squared equal to 4b plus 3. 4n square plus 4n plus 1 equal to 4b plus 3. 4n square plus 4n minus 4b equal to 2. 4 times n square plus n minus b equal to 2. And n square plus n minus b equal to 1 over 2. This shows that A5 is contradicts with A. Condensed proof. Assume to the contrary, a square minus 4b minus 3 equals 0, and a and b is z. Hence, a square equal 4b plus 3 implies to 4b plus 3 is odd, so a square is odd too. Let a equal to n plus 1. Therefore, a square equal to n plus 1 squared equal to 4b plus 3. 4n square plus 4n plus 1 equal 4b plus 3. 4n square plus 4n minus 4b equals to 2. And 4 times n square plus n minus b equal to 2. And lastly, n square plus n tolak minus b equal to 1 over 2. And this contradicts the initial assumption.
Okay. In conclusion, logical thinking is a critical skill that not only supports sound decision making but also contribute to more effective communication and problem solving. By developing a solid grasp of logical principle, individual can approach challenge with greater precision and clarity, minimizing error and enhancing their ability to make well-reasoned conclusions. This foundation of logical reasoning is essential for navigating complex situations and ensuring objective, unbiased analysis.